Welcome to Austin Python. This is the, what month are we in now? June. The June version of this. We're halfway through the year, a little over halfway of our meetup since we don't generally do one in December. Thanks everybody for coming out. The beverages and food tonight were brought to us by Cloud Hashing. This is Lucas from Cloud Hashing. Wanted to say a few words about the company.
Thanks for having us. This is a huge meetup. Awesome to see so many of you guys here. We are a local Bitcoin mining company, and we are seeking an amazing Python dev. So just wanted to come, give a quick pitch to you guys. I won't take up a lot of your time, but essentially up until this point, we've mined about 35,000 Bitcoins. We're the largest Bitcoin mining company in the world. We have an office up on about 183 in Breaker area, and we are looking for an amazing Python dev. I'll keep the details short. I'll let you guys get on with your meeting. But David and I, David Cloyd is our operations manager, and I'm Lucas. I'm the president of the company. We're going to step outside, and we've got some flyers with more information on it. We'll leave some in the back as well. Don't want to take up too much of your time, but we are looking for somebody good. Yes?
Tell us one thing about Bitcoin mining. What do you mine then? What's the developer going to do?
That could turn into a very long conversation.
What's the developer going to do?
Oh, you're talking about the developer?
Yeah.
So,
what the developer is going to do?
Yes. So essentially, the front end and the back end of the website were developed around Python. That's the original developer that came in and built the site and built the back end. It's a pretty complex mining system on the back end. The front end is fairly straightforward, but that developer has gone on to Silicon Valley and another part of the company, our sister company, our parent companies in Silicon Valley. So our lead dev is up there running the mining back end, and at this point, we're looking for a programmer to take his place in Austin. So this person will be responsible for essentially, at this point, we're looking at recreating the front end of the website to integrate with the mining back end, sort of the mining pool and the mining interface. We sell consumer contracts to users anywhere from $300 to $3 million all over the world. Investors come to us to invest in mining Bitcoin. So these contracts go live immediately. We're one of the only companies in the world that can do that. We have about 4 petahash on the network right now, and we control roughly about 5% of the Bitcoin network on any given day. So these contracts go live. The users generate Bitcoins instantaneously get payouts, and then interface with our website to get their statistics, their data, their investment, their returns, and all of that. So we're looking for somebody that can really, at this point, almost rebuild the front end of the website and integrate with the back end, because there are sales and marketing efforts that we need to do from the Austin perspective that don't necessarily tie into the back end, and we're looking for somebody to do that. Yes?
You pay in Bitcoin?
We don't, just because there's still a lot of crazy tax issues around it, and right now we're actually integrating our accounting software to be able to do that potentially. So up until this point, it's just been sort of crazy because there haven't been a lot of guidelines and a lot of laws around it. And even now, the tax benefits of getting paid in Bitcoin aren't what they used to be because the IRS ruled on it that it's essentially capital gains. And it's taxed as if you were being paid in a commodity like a stock or gold or something. So the benefits of getting paid in Bitcoin are not what they used to be 12 months ago. Essentially, it was almost like a crazy tax haven 12 months ago, but not so much anymore. Does anybody else have any other questions? I'll give you a quick rundown. We're looking for somebody with experience in a Linux-based environment, Python, C++, Java, JS libraries. E-commerce experience is huge plus, just because of what we do in dealing with consumers. And that's pretty much it. We've got more information on a sheet of paper that I can hand out to you guys, and also, talk with you. David and I'll step outside if anybody wants to chat in more detail, and we'll do some of these out in the back as well. But thank you guys for your time. Appreciate it, and cheers. Have a good meeting.
Perfect timing on that. So I think there's still a little bit of pizza back there. There was actually 2 full s'mores. So if you like sausage and spinach, there's a really good pizza back there. Our first talk is going to be Bob talking about DistArray.
Thanks. Thanks everyone for coming out. My name is Bob Grant. I work for InThought, just around the corner. And I'm not the only one working on this project, but I'm Robert Grant. I'm working on a team of people at InThought, top row. So, and all these other guys are here. If you want to quiz them about DistArray afterwards, feel free. And all this work is based on some earlier work by a guy named Brian Granger, who works on the AppPython project. Just wanted to point that out before we get started. But before I get started, I wanted to get a feel for for what kind of Python programmers you guys are. Not everyone is in this space. I realize that. But so first of all, show of hands, who of you has used NumPy before? Oh, good. That's a lot of you. Okay. How about IPython parallel? Okay. Anyone written any MPI code? Okay, very few. Okay, that's good. It's good that you're all familiar with NumPy, because this is heavily based on NumPy, and hopefully a lot of this will make sense to you. But feel free to interrupt me with questions. Okay, so what is DistArray? DistArray is a project, an open source project. It's funded by an SBIR to create distributed NumPy arrays. So really, it's a distributed array object on top of NumPy arrays. And it's built for data parallel problems. Hopefully, a lot of the things that you would use a NumPy array for, you'll be able to use DistArray for to get some easy parallelism. We hope to make an easy interface to doing parallel operations on a data structure like that, as well as giving you the control to get down and do local operations close to the data if you need to. But it's BSD licensed, it's on GitHub. You'll see all my slides have the GitHub link here at the bottom, so feel free to go check it out. We would love to get some early adopters. So I do want to point out, we just made a 0.3 release. It's not production ready yet. The API is going to change, and we're still testing it and playing with ideas. We'd love to get some early adopters, especially if you work in this kind of space. We'd love to get your feedback on that. And it does work on Python 2 and 3 from the same code base.
What about 3.4?
I haven't tested it yet, so we'll see. It's Travis doesn't have 3.4 yet, I don't think. But so we build on top of several widely used libraries that are used all over the place in the Python scientific stack. So NumPy, a lot of you knew. IPython parallel is a part of the IPython project to get parallelism. MPI for Pi, which gives an interface to this the message passing standard. So this fast message passing library that's implemented. Many people have implemented very efficiently. And optionally, libraries like H5Py, so we can interface to things to save and load from HDF5 files, which is important to a lot of people in this space. And we would like this project, so we're building on top of all these, but we'd like to be able to interface with a lot of these libraries that are already out there that have some sort of distributed array functionality. A lot of these are written in languages like C++ or Fortran and have Python layers on top, like PyTrillianos for Trillianos. We're working with Bill Spots on the Trillianos project, and we talked to Jeff Daly with global arrays. Have any of you used any of these libraries in here? A couple people. Okay, so a couple of you know what these are for. So various libraries for doing distributed linear algebra or solving PDEs, things like that. And we would like to be able to import arrays from those libraries and export arrays to them and call them from DistArray if possible. Okay, so it seems like a lot of you know about NumPy arrays. I'll just mention briefly why we're building on NumPy arrays and how they're different from a built-in structure like a list. So unlike a list, NumPy arrays are generally filled with data of a single type. So, and they're also could be of various dimensionality. So you can have a one-dimensional, a two-dimensional, or a three-dimensional NumPy array. And it's usually of a fixed size and filled with a data type that NumPy provides several data types in addition to the built-in Python data types like 32-bit float or 64-bit float or several data types like that. So this would be an entire array filled with this data type. And why we would want that is that, so under the hood, given these restrictions, this can be a very memory efficient data structure. We can write compiled code in C or whatever to use this data structure and to loop over it for us, and then write nice Python code on top to use it. So we can have this nice, compact, efficient data structure that we can then use from Python. That's why NumPy is the basis of all these different scientific libraries in Python. And so what DistArray really is so pretend like you have an NumPy array, and its chunks just happen to be distributed over multiple processes on your machine or multiple machines. Basically, right now, anywhere you can put IPython parallel engines. And DistArray is meant to be an abstraction over that looks like a NumPy array, but under the hood, your data is distributed. That's the idea. And so the way that we implement this is by using IPython parallel. What IPython parallel lets you do is start up several Python processes called engines. These engines can be on your laptop, or all on a remote machine, or on several machines. And then you have an object called a client. There's a couple other things I'm leaving out here in IPython, but this is generally the idea. It's that you have a client object that you use that controls your access to these engines, and you can push data to your. These engines are all basically Python processes, and you can push data to them and apply computations on these engines and then pull data back. And so usually IPython parallel uses 0MQ to do this communication. You can also fire up engines that go by MPI if you want to do MPI communication between your engines, and that's the way we're using IPython parallel. And so this is how we've implemented this abstraction here. So you make a DistArray object on your client. This is something you can play with in a Python prompt. It looks a lot like a NumPy array, hopefully. But behind the scenes, whenever you call a method on this DistArray object, it's sending messages to all the engines to tell that the proper operation be done on whatever subset of your data happens to be on each engine, which we call the local arrays. Remember, all these local arrays, inside them have NumPy arrays. But this abstraction we give you, hopefully, a lot of the time, allows you to forget about the fact that you have different chunks of your array on each of these engines. And one bit of terminology I want to point out is, so a lot of times in this space, we use the terms global and local. Question?
Finn,
Yeah.
why are you using 0MQ to go between the client and the engines?
Because that's what IPython parallel uses.
That's what IPython uses.
That's right.
IPython server and client.
So we're just building on IPython parallel.
Because it's a curious choice with an API infrastructure.
That's true, and definitely, especially after talking to people who might use this, people are definitely interested in an MPI-only communication layer. And so that's definitely one of the goals. So just the terms global and local, which I might throw out, and I want you to know what I mean. So when I say global, I'm talking about a global view of the array. That's this NumPy view. I pretend like I have a NumPy-like array that I'm playing with. This is the global view of the index space, you could say. And that's as opposed to the local view. And what local really means is the view of these local arrays on engines. So a close-in view on one particular engine is a local view. And that can be confusing if you start thinking about these engines as being remote, then local sounds like it doesn't make sense. But global is the global view and local is the local view. So one thing I haven't talked about too much yet is so I have this NumPy array, but I might want to control more specifically which chunks of my array go on each of these engines. And we do allow you to do that in DistArray. There are some defaults, but you can also have very fine control over that if you want. So here's a diagram, and hopefully most of you can see this, that shows the default, the easiest way that you might distribute an array over a bunch of processes. So in this case, I have a diagram of, so I'm pretending I have 3 processes running, or 3 engines, and I have a 5-row, 8-column, I think that's what that is, 9-column matrix, or array. And here this is what's called a block distribution, just meaning along this, we're just considering the first dimension, the rows. I'm distributing the rows evenly over all my engines. So since I have 3 processors and 5 rows, I have 2 on the 0th process, 2 on the first process, and 1 row on the last process. So that's the simplest way, and that's usually the default distribution that you get. And this is the global view, and this is locally what those arrays would look like. You just have chunks of it on each process. Question?
Could you resize the x dimension so we're distributing it more evenly across the data for processes? Right.
So in this case, it says block, comma block, but really the columns are not distributed anyway over there. This is a 3x1 process grid, you can say. But if you wanted, you can distribute all the dimensions and however you want. You can be very specific about which ranges go on each engine. And I'll show a couple examples of that. So for example, here is, instead of distributing the rows, I can distribute the columns. Same setup, just a different block distribution. Only in this case, I have 3 columns of this array on each engine. And there are a few more of these, and so if you're familiar with some of these distributed linear algebra packages, one reason aside from load balancing and things like that you might want to have different distributions like this is a lot of these packages expect different distribution types, and we want to be able to work with them. But we support one called cyclic. That's from those distributions, those packages. Also, you can arbitrarily assign whatever indices you want to every process. That's supported. Okay, so that's a little bit of an overview. See how much time I got? Doing pretty well. So I'm going to pop over to an IPython notebook and show you what some actual code looks like. Okay. And please let me know if I need to zoom in even more. So all of these DistArray examples assume there's an IPython cluster running. So I have these engines available to me somewhere. And we have with DistArray, we ship a little wrapper to IPython's cluster management to make this easy. It's called DA cluster. So first I'm just going to import some utilities, pprint and matplotlib. My main imports here are NumPy and DistArray. And I'm basically going to compare the two, and hopefully you'll agree that DistArray has a pretty NumPy-like interface. So here's an example of a 2D NumPy array, a 2D random NumPy array that I made. And arrays like this, you guys in the back, can you see this? Okay? Yeah? Okay.
Open up just a little bit.
Sure. Great. And so an array like this, we expect to have some attributes. So the type of the array is a NumPy ND array. The D type is the type of the data within this array. This happens to be float64. It has a certain number of dimensions to a shape. This happens to be 4 rows and 5 columns. Then an item size, which is something you don't get in something like a list. You see how many bytes are actually in each of these points of data. And then the number of bytes in the entire structure. And hopefully if you multiply the shape, so we have 20 elements times item size of 8, should give us the total number of bytes in this array. And so if we wanted to do something like that in DistArray, it looks pretty similar. Ignore this context right now, but so the first thing I'm going to do, this line, I'm going to use a method called fromArray, and it's going to take that NumPy array and make it into a DistArray. This is doing some default things for you under the hood. It's going to take this array and distribute it out to the engines with some distribution. And so you'll notice when I just put this into the interpreter and run it, I don't get back a representation of all the values like I would with the NumPy array. I just get back this representation. Just tells me the shape and targets is which engine it's on. And the reason we want to do that by default is this is hopefully going to work with very large arrays. And we want the user to have to be explicit when they want to actually pull data from their engines back to their client. Taking a NumPy array and distributing it is nice for playing around, but we assume that won't be the common use case for doing this, because maybe you don't have enough memory to fit it on your client machine.
So when you say large array, what sizes are you targeting?
Kurt, you got a good estimate there?
We don't want to put any restrictions, really. So fairly, large simulations down to, scaling down to fairly reasonable sizes that will at least give you nice parallel speed up. So.
I no longer work in this world, so the numbers I know are from ancient past. So if you could give me a guesstimate, are we talking, gigabyte size arrays?
Sure, larger, yeah. I mean, it's really a matter of what sort of hardware you're running it on. Running on a massive supercomputer, then you're going to have arrays that are just absolutely non-bottling. So, scaling up to what all the memory on those machines can handle. So down to, but we also want it to work on a local machine as well, on a laptop, and scale to those sizes too. So we really want to make it open-ended in terms of sizes.
So that, may I ask a follow-up?
Sure.
So if you want it to run well on small machines, does that mean inside the machine multi-processing happens quite efficiently in this context?
Yeah, we're building on top of, we're handing off a lot of that part of things to MPI and using the existing MPI optimizations, implementations for that sort of thing. But as Bob will show, you have a lot of control over what's happening local to the data, so you can be right next to the data, handling it right there. So,
Thank you, thank you.
sure.
And so although we want this to be easy to use, of course, to get all the performance possible, you'll have to know what's going on and where your data is and do exactly what you want only when needed.
So would you see some benefit using this on like a small machine, like a laptop or something? Is there some procedural process where you want to do that?
Sure, if you have multiple cores, then you can fire up some engines and do some computation in parallel.
Right, but if you've got multiple cores on a single laptop, you've got one memory, they can all access it, so this is surely going to add some overhead over and above. Just having a single
That would add some memory overhead, yeah, so it kind of depends on your trade-offs that you're making.
So I'm having trouble understanding why you'd use this on a single machine. I don't see the value, or maybe you've got benchmarks to prove it, but.
We do not yet.
Okay, but I don't see the value if your data sets fits in a single memory. Because the code is going to be an awful lot simpler, and you don't have to worry about where your data is.
If you have a CPU-bound computation, you'll get a speed up, and you'll utilize most of your cores effectively.
Okay.
If you have a memory-bound operation, you're on a single machine, you're just going to be hitting your memory bus the whole time. So you're going to have to distribute it in order to have separate machines, each with their own memory bus dealing with that. So if you're local only, you're going to need to be restricting yourself to CPU-bound stuff. But another point of this though too is just at least being able to load and play with large data in a nice way is still worth something. Even if it doesn't scale immediately, you can at least play with stuff interactively and get a sense for what's going on. Then you can say, okay, I got this framework, and then from there you can get the performance and the scalability you need with some of the other, I guess, intermediate level features we provide.
Yeah.
Okay. Thanks.
Okay, so this is a simple example, a small array. But here we've made a random array, or we've made a distributed array out of this NumPy array. And just showing that it is indeed, if we grab the local arrays back, we see that there's one row per process right now. And DistArray has very similar attributes to a NumPy array, all these same attributes that I showed before. But there are a few extra, which I've talked about a little bit already. There's a distribution which controls which ranges exist on each engine. Which engines we're using is the targets. And the context is something I'll talk about a little bit later. So some of the features that you expect out of a NumPy array, one of the main things is universal functions. So universal functions are these functions that you call in a NumPy array, and they operate element-wise over the whole array. So something like sign. We can call numpy.sign on our NumPy array and get back another array. Every value is the sign of the value from the original array. And we can also do that in DistArray. So DistArray supports ufuncs. Notice in some of these examples, I am going to bring the DistArray back to the client and cast it and make it back into a NumPy array just for display. You probably wouldn't normally do this. You would probably do all the computations you wanted and maybe grab out slices or parts that you wanted to display or analyze or do something else. Do some kind of reduction before you brought it back to the client. So you can also add two NumPy arrays together, do binary ufuncs, and that same sort of operation happens. You get, for every element of the NumPy array, you're adding those two corresponding elements and producing a third. And we do that with DistArrays also. That's just a couple of simple examples of ufuncs. And then so the distribution. I've mentioned that you can control this more specifically, or you can use the default. So what I'm doing on this first line here is just using the default distribution. So I made a distributed array out of a NumPy array. I didn't tell it anything about how I wanted it to be distributed. And if I print out what that distribution is, what it's telling me here is that the 0th dimension is a block map, which is that default distribution I told you about before, where the rows are, the 0th dimension is distributed evenly over the available engines. And the first dimension isn't distributed. And so you've seen a plot of this already, but here's what labeled, the colors are labeling which engine this is on, so 0 through 3. And each row is on a different engine for this particular example. Question? So
it inspected your machine. Is this all running locally? I assume it inspected your machine and chose that forward.
The context knows how many engines are available. That's what's going on here. And it distributes evenly over however many are available with this particular distribution.
So you've already fired up 4 engines.
That's right.
Okay. So you did that at Detox.
These are running in the background. And I can check the particular bounds if I want it. In this case, it's just 1 row per engine, so I get 1 row per engine in my bounds. Question?
Yeah, when you're working with the binary U-funcs, do you have to have arrays which are distributed similarly, or they just have to have the same like abstract shape?
Right now, I'm pretty sure they have to be distributed identically. That's not something we always want to be the case, but that's the case right now. And Kurt's working on redistribution right now, which is one solution to that.
Yeah, that'll allow you to line into arrays that are compatible from NumPy and distributed.
Changing the distribution in place? Or?
We're filling out performance aspects of that, but yeah.
Great. And so that was the default. To show you how you might make a more complex distribution. So first I'm going to make a distribution, in this case from some basic parameters. So we're used to making an NumPy array from a shape. And in this case, I'm going to say I want the 0th dimension to be block distributed and the first dimension to be cyclically distributed. And what the cyclic distribution does is, instead of assigning ranges, say of this dimension to each engine, it distributes the indices round robin style. So the 0th process will get row 0, or column 0 in this case, the first will get 1, the second will get 2, and then it will go back to the first and give number 3 to 0. And so then I'm going to use one of these DistArray creation methods, zeros. So it's called on the context, you'll notice, which is something I'll talk about in a minute. But the zeros function is just like the one in NumPy, only we're making a distributed array. And we're giving it this distribution to tell it where to place all this data. And so this is a more complicated distribution. The rows are distributed differently than the columns, and there's data all over the place. But it's exactly how I want it. And so just to mention this context object, the context is something that knows about which targets are available and handles the communication between the DistArray object and these local array objects that it's managing. The DistArray is kind of like a proxy object. And so a lot of these methods you'll see, for example, context.zeros are called on the context. And that means that the zeros are placed on this set of engines, on the set of targets that it knows about. And so that's the basics. Now I just wanted to show a few of the features that we have in place so far. Of course, there's a lot to be done. We would love to get some contributors, but I'll show you what we have so far. So we're on version 0.3. We just released last week, I think, maybe 2 weeks ago. And so before that, we already had some I/O support. So we can, for example, load a NumPy array in parallel and on several engines, load in different pieces of this distributed array. So if you're familiar, NumPy has its own binary flat file format, .mpy, and this is what we can load in. Well, so here I'm saving example 1. I'm making a new distribution to tell DistArray where I want it to put all these parts of the array when it loads them in. And then finally, I'm calling load NPY and loading in this file given a distribution. We can also save and load HDF5. This is sitting on top of the H5 library because that has the functionality to use to build on top of MPI and give us that functionality. And also, if you don't have, it can be a pain to build HDF5 libraries and that sort of thing. So there is a distributed file format that comes with DistArray called .dnpy, which builds on top of the NPY file format and just adds this additional distribution information to each file it outputs. And so a pretty recent addition is sum reduction functionality. So in NumPy, it's a simple matter to do something like a sum. So you can sum an entire array by doing array.sum, or you can sum over a particular axis. So if I sum over axis number 1, I get back not just a single value, but multiple values, a value for every column. And so that you can see how this could be more complicated for a distributed array. But we can do these simple sorts of reductions over the entire array or over particular axes with the axes argument. There are some that are not implemented yet that are coming soon. Okay, so now in the few minutes I have left, I'll go over a couple more features and open it up for more questions. So if you do want to send functions to your engines and compute locally on these local arrays, so you're not just relying on the built-in DistArray methods. You want to write your own function to compute on these local arrays. Or maybe you want to write a local function that uses MPI for Pi directly. You want to write your own MPI code. You can use the apply method on the context object. So I can write here's a simple function, get local random, that just generates a random integer on each engine with NumPy. And then apply, calls this engine, this function on every engine and returns the result. This is a pretty simple apply example. Or a slightly more complicated example where I pass in a distributed array and the local function on each engine operates on its portion of this local array. I can also pass in arguments and keyword args. And finally, so coming soon, we just released 0.3 and 0.4 is coming soon, is slicing. So slicing is important for NumPy arrays, and it's going to be very important for distributed NumPy arrays. The reason being that when you do a slice, so for example, here's our original array, just as a reminder, distributed over various engines. When you take a slice of a NumPy array, you get back a view on that array. So you're not copying the data by default, you're getting back a view on whatever portion of the array you're selecting with your slice. So here, I'm taking a slice that's all of the rows in the third column of that array. So it should be 0, 1, 2, 3, this third column, which I can grab out of my distributed array. And then, aside from, additionally to that, if I modify one of the values in that slice, both my slice is modified, and the original array in that position is modified as well, because it was just a view over that original array. And so if you're not familiar with NumPy, the slicing syntax is the same as for lists, only you can apply it to every dimension in your NumPy array. And so here, what I'm doing is a more complicated slice. So here I'm asking for all the rows, start with the second column and go to the end, to give me every other column. So this is a much more complicated slice. I can still grab this out and still set particular values on this view. Views are especially handy. You could imagine if your data is distributed and too large for you to pull all back to your machine, you may just want to select portions of it and either pull it back or reduce it and do some computation on it. And so finally, I mentioned this interoperability a few times. The key to this interoperability is almost a separate project, a spec that we worked on in collaboration with several other people, the distributed array protocol. So this is a Python protocol, a data structure basically, that we can export from locally on these local arrays that says exactly how this data is distributed, what indices are on this process, and where its position is in the overall array, and what its distribution is. And so if another library supports this protocol, they know how to import this array without copying the data, is the idea. So it is so we do have to provide very specific information, so it's large, but all the data is there, and that's what we were working with the Trillinos folks and the Global Arrays folks to implement, export and import of this protocol data structure. All right, and so I'll just put up our roadmap. There's lots more to do, obviously. Some of the NumPy features that you might want are broadcasting and fancy indexing. MPI-only communication is definitely one of the features that's been requested. So a lot of things to do. Please check it out on GitHub. Are there any more questions?
So I have kind of a quick question. So when you instantiate a distributed array, is that when it's actually dispatched to the engines? Is the memory actually copied over when you instantiate it?
Well, that's one way you can do it, but it's probably not what you usually want to do. Like you can use from in the array and actually push chunks. But something else you might do would be to load in an HDF5 file in parallel on each of your engines. So not actually push the data, but have each of your engines load in its own part.
Okay. Then the second part is, so for a lot of linear algebra operations or any common matrix operations, you think the actual distribution of the data depends largely on what the operation is. So
The optimal distribution for doing that, you mean? Yeah.
exactly, like how you slice up your data depends largely on what you're doing with it.
Right.
So in that context, is there any sort of any way to define a distribution such that at the actual operation point where it's doing an operation, it'll pick the right distribution to redistribute data?
Well, so we don't have redistribution in place yet, is one answer. Another answer is, this is one of the big reasons we want to be able to interface with libraries like Trillianos or Elemental, which are very optimized for doing distributed linear algebra. So we want to be able to give them arrays and have them figure that kind of thing out partially. And we do. This is also one of the reasons we support these different distribution types. For example, SkullAPAC has the block cyclic distribution that is efficient for many types of operations, and we can build an array with a block cyclic distribution.
Describe efficient operation. For example, something simple that most of us can understand: matrix multiplication.
Okay.
I saw that you distribute the information and you can put it in different ways on different machines and manipulate it those ways.
Right.
But once you start doing the matrix multiplication, some things happen, have to pass between nodes and things like this. Do you manipulate those?
Well, so we don't have operations like matrix manipulation or multiplication implemented yet, for one thing.
Okay.
And you're right, there are going to be some operations where you have to move data around. And that's also something that we're working on. Right?
Okay. Thank you.
Unless you, yeah.
Is there sort of a general reduction construct within this array?
We have the components for someone to write their own reducer.
Okay.
And say, here, use this for the actual reduction operation, and then put that folds into the system.
You could write your own matrix multiply at this point.
Presumably you could, yeah. Although one part is that we don't want to be, a lot of work has been gone into over decades to get distributed matrix multiply working really well, right? So part of the idea is we want to just let people have a very easy interface to create these arrays, right? And get their data in there without horrible performance and good scalability, and then hand off that problem to one of your libraries that already existed. And so that's why we want to have this protocol that Bob mentioned at the end, to let someone say, here's my array, Trillianos take over, or Petsy take over, do the actual hard core computation, right, without copying any data at all, and then give me back the result, again, without copying.
So do those libraries tell you where to distribute the data to?
Basically, the protocol tells those libraries how everything's distributed. They take that information. They would have to implement the receiving end of the protocol. They just have to say, okay, got this data structure. You're describing exactly how things are distributed. I'll take that, create my array internally, do my internal computation, get back the result, and then you're good to go. So part of it is just a really nice, easy interface to these, to these scalable libraries.
And one thing we expect that people will want to use this for is wrapping existing NPI code, for example.
The question is about the protocol. So you said that it was kind of a separate project.
Well, it's a specification.
Well, yeah, but the design of the protocol is separate from the distro project necessarily.
That's right.
So was that designed with input from the communities around these giant libraries you're trying to use, or?
Yeah, we have input from 3 groups currently, and we want to get input from others. But we feel right now it's general enough that it can handle several distribution types, and it's not locked into any one particular library implementation. But of course, the more people who implement it and look at it, the better. But yeah, it's designed to be independent, and it's kind of self-standing that way.
Have any of the other people that contributed to the design of the protocol committed to implementing the receiving end?
That's in the next few weeks. We're going to be getting that going, working with the 2 other partners right now. And,
but yes.
Working, so.
So, is there a plan for dealing with third-party libraries? Like, say, I have several petabyte or exabyte file and I want to take a histogram of that and plot it in Matplotlib. And have Matplotlib do everything with DistArray under the covers.
Right.
So what is there? That didn't seem to be on the roadmap, or what's the?
It was. You mean distributed plotting in particular?
Well, not just plotting, but you have this issue where you've got some other code that uses the NumPy API.
It's true.
And it doesn't seem like the API you've implemented to date. Now maybe that's down the road. Is 100% NumPy compatible, right?
That's true.
And you can
That's true.
go into sys.modules and just swap out the library. So what's the story there going to be?
So that's true that it's not 100% NumPy compatible. We wanted to make it as NumPy compatible as possible, but that turned out to be pretty inconvenient in some spots. And and so, for example, I don't know exactly how that's going to work out yet myself. I don't know if Kurt has ideas on that, but we definitely are talking about things like distributed plotting. What kind of reductions people are going to want to do to view these large data sets. So that's definitely an open issue.
So, little addendum there. So, we're definitely talking about a NumPy compatibility layer on top of this. So, someone that uses just the NumPy API could get something that works with this. The performance might not be nearly as good, but at least it would work, right?
Right.
So there's that, and also there is still the ability for someone to control things at a very low level. So if they need to, they can choose what level they need to go in and make things work for their particular problem. At least, so there's a path forward for people to at least get things working in the interim.
Okay.
You have a question? Awesome.
That was pretty much my question.
Great. Thanks.
So we're going to take about a 10-minute break, and we will be coming back with Ramesh talking about Pandas. Normally this is the time we would be calling for anybody that had any lightning talks they want to do. Tonight, so we've got 2 full talks lined up. We're going to be not doing lightning talks. I think we're going to run out of time. But we've got some more beer, and there's still some soda up here. There might still be some pizza in the back, so help yourselves, stretch your legs, and then we'll be back in about 10 minutes.
So the live stream? So the mic. No, it's turned off.
One of my good friends just over Dan. Yeah, that's what I asked what you do. That's I said she's doing similar stuff.
It kind of validated some of the things that I was feeling myself. I kind of felt like maybe I was just kind of complaining about the way markets work or something, but now it turns out that I'm not the only one who sees it that way. It actually is the way it works. Like one of the things we pointed out was like, like people who are in the incubators category, they tend to not want to pay any money. I almost experienced that so much. And I was wondering if like I was just
already have to make it. I don't have to hold make these. Main architecture of
that's right. I just want to do this.
Oh, you're
Like I have to keep my there's like some software concept and like literally like okay, so there was going down a program and I took it almost and I was like
which I guess, for me, what I got from looking through it is very easy to just dive in.
Right. Right.
And that was very
Yeah, no, my message actually is I've done a lot of things with SQL, and I always look at Pandas. I've looked at Pandas in the past and said, oh, you know what? I should do this in SQL. I don't need Pandas. Until I started looking into it the last 2 weeks. You can do things that you will find hard for us to do in SQL on your own. Not only you can do it efficiently, you can actually do things that you just cannot do in SQL. One. The second thing is you can read JSON file. You can read so many different formats and can do text mining. Right? You can do so many things that it could be you can think of it as steps before you put things in the database. So my goal is for people who have not used Pandas to actually get excited about it and then do something with it this week. That is really my goal with this stuff.
Right. Or say, look how easy this was. Can you do it? It will get people.
Right.
Classic. People look at scientific computing and they see things that it seems like we just saw.
Right.
That was a good talk on this story.
Right.
You don't actually have the problem.
Exactly. Yes. I'm hoping this is actually a good segue because this is a small data set. This data set has 1,000 rows, right? It's not a large data set. So you can load it up in Excel and you can try to do some things with it. But I'm hoping to show that you can actually do things in this that you cannot do in Excel. Right. This is
Where's it at?
What I'm worried about is if I put too much out, then it's going to be a problem and the output start to show up. Scroll down it's not the data right
This is why.
I'm like, I should
Okay, everybody, everybody can get back to their seats. So Ramesh is going to talk to us about Pandas, the statistical analysis library. Is that what you're describing it?
Data analysis
Library in Python. This is part of a series of talks that we kind of have coined as the Pythonic talks, sort of intro to different parts of the Python ecosystem and the language itself. If you're interested in giving one of these talks, every month Andrew Donahoe sends out an email to the mailing list saying, hey guys, get ready, send me your ideas. Respond to that and say, hey, I would like to talk about this. One that I still want to see, that I have not seen anybody give yet, is the import statement in Python and how it works. There is some black magic that you can do with import hooks that gets really, really crazy. And like it seems like, oh, you just from something import something else.
Sounds like a volunteer.
No, I'm just saying it's there. I'm not saying I'm good at it. Somebody that wants to give a talk should definitely investigate this and do a talk on it. There's some really cool stuff there.
Can I interrupt for a second?
Do you want to?
What do you guys want to hear? Does anyone have any ideas for lightning talks that you can't do yourself, but you wish somebody else would do?
Don't all talk at once. There's got to be something somebody's imported once and I really wonder what happens here. With one talk, this is going back. This is 2-3 years ago when we were over at the InThought offices. We had a talk on regular expressions in Python. How many people know that there are 3 regular expression libraries in Python? Like, all I ever do is import RE, but there are apparently 3 different ones, and depending on the use case you have, you might want to be using one of the other ones. So there's tons and tons of stuff in
They're not in the standard library.
True, there's only one in the standard library. But there's tons of stuff in the standard library that there's plenty of fodder for talks.
So let me ask the group here. As many of you know, I write iOS, iPhone, iPad software, and Apple just announced a new language called Swift, which has a lot of Python ideas in it. Would this group like to see someone who knows iOS actually describe Swift to you guys?
Yes. Yeah. No, other languages are always a welcome thing.
Well, I'm happy to. I just didn't want to propose it if it was boring, because it's a very narrow world for me. So most of you don't know.
Yeah, one thing we've always talked about doing is like a X for Python Pythonistas. So your favorite language. We did lightning talks, I guess, last month or 2 months ago. They were just like a quick, here, give me a 5-minute intro to the language you use and why it's important.
There's nothing 5 minutes about Swift. It's going to be an hour. And then I'm talking, so it's 2.
Yeah, no, we should definitely set up a series of these talks that would be like some. Yeah! How many programming languages are there that have some connection to what people do in Python?
But wait until Xcode 6 is actually free, so
So we'll wait till September.
Maybe we start when the school year comes back because attendance goes back up then.
I mean, I have students already asking me to teach my beginning iPhone class in Swift. So
cool.
It should be available in September.
You have a question?
Lightning talk on Bitcoin.
Ooh. If anybody here does anything with Bitcoin and would like to talk about it.
When's the meeting next month?
I don't know when the Bitcoin meeting. Oh, the next Python. There's a Bitcoin meetup. That's right. The next one is the second Wednesday of July. No, is it second Wednesday? We're second Wednesday. Yeah, second and fourth weeks. Do you know much about Bitcoin and like share, or any about Bitcoin and like share?
I could talk about it for a while, but I don't know if I'll be here next month during the meetup. So.
Well, if anybody's got anything that they're even thinking about talking about that they think they might be interested in, shoot an email to the organizers on the Meetup group. That hits all of us that are involved in organizing it. Do you have something?
No, but you know Sci-Fi is happening at the same time as Detox next month.
Is it really? So we will figure out what's going on. We may do something involved with Sci-Fi. Actually, in years gone by, we've had speakers that have come in for Sci-Fi do stuff around Austin Python. So we may have that happening again. There'll definitely be announcements on the Meetup group, especially we're going to have somebody international in. So keep an eye out for that. Well, without any further ado, we'll let Ramesh talk about Pandas.
All right, thanks.
Right, can you hear me? It's good? Okay. I might leave my mic down after a while when I start to use both hands on the computer. So it's a perfect segue because I'm going to talk about small data. So I have a data set of 1,000 rows. Pandas can work with 1,000,000 rows and 25 columns. I've done with the Walmart sales data set over 2 years, but today I'm going to use a small data set which I downloaded from Kaggle, which is really, let's see here. Okay, hopefully it's that. So it's, that's no IPython over there. So, which is really some small data sets about Titanic disaster. So it's kind of easy data set for all of us to understand and see how Pandas makes data analysis happen in Python. So, okay, let me bump up my things here. All right, so on the outside, I've not done Pandas a lot. I've done it last 2 weeks now. And one of the things that was holding me up from going into Pandas is I said, oh, I could do this in SQL. I could totally do everything in SQL. I don't need Pandas. And I could do the query in SQL. And I hope to change that mindset. Okay, I hope to change 2 mindsets today. One is you could do everything in SQL, or 2, you don't need anything, you just need Excel to do this. I hope that at the end of this, you will see that things that Pandas makes you do, you just can't do in Excel or SQL, and even for this small data set. And when you talk about larger data sets, Pandas makes way cooler things. And we're not even talking performance and speed and reproducibility. We're not talking any of that. Just doing this thing in any other system is hard. So I will just import the libraries here. So here's where I may actually put my mic down. We'll see. Okay, there you go. So I just put my versions in there just so that you know what versions I'm using, because Pandas has been, the APIs has been changing a little bit, and I use Python 3.4, so why not? So that's my approach to things. So here the display options, Pandas has a lot of display options. I'm setting the display options to max rows at 15, and you will see why. And you could change that. I just want to put it out there so that you can go and modify it and see how that changes what you display. So here's a reference to the Kaggle Titanic dataset that you could download and play with. So I have downloaded the data. It's a CSV data, and so here it is. And so I actually right off the bat, all I did is Pandas read CSV, right? And there is Pandas read JSON, Pandas read SQL. Pandas has a lot of I/O modules, and you can read any data in Pandas. And so that's one of the amazing things about Pandas is you could directly read JSON file, which most SQL database probably will not do. So that's right there. And it can do a lot of things with the string manipulation and string munging, which I'm not going to necessarily go there, but you will see how it makes it happen. So by examining this data frame here, you would see it's basically a simple table. It's basically a table with columns. So you see passenger ID is a column, survived, P class name, age, sibling. So we're going to primarily look at the survived column, who survived, who did not survive, and can we understand, so we're going to ask some questions out of this. So can we understand, so looking at this just tables of data, right, it's not going to be that much useful, right? There is 891 rows, 12 columns. By setting max rows to 15, I'm actually able to see only like a short set of rows here. So I can totally say max rows is 5 here. And that would, if I go in there and try to do this, that only show me like 5 rows. So that's how you could use max rows. It's just what you display over there. It's not for anything else. So right back to 15 for a reason here. So go down here. So this is my mental model of how I look at Pandas. We all understand columns. So it's just column after columns, and then it's got an index which you don't have to know to use Pandas initially, but you would get to know it as you use it. You see that index can be a very powerful concept, but you don't have to know index to use Pandas. So first thing is, let's just examine what data is in there. So I just say, okay, columns, it tells me, okay, there are these columns in there, and I can do a describe on Pandas, which is very similar to the R statistical language of summary. So you could do summary on data framing R, very similar to this. Tolly came from there because Gus McKinney used R before this and wanted to port R data framing to Pandas. So there's a lot of similarities in the API and stuff. Although Pandas is a lot more powerful here. So here, describe. So you see that each column, it tells you how many rows are there, which is really nice. Is what these rows are is not null rows. We'll go to that here. So you see there are 714 not null rows, which means that there is about 150, 175 passengers, for whom they do not have age for, right? So there's no age that they are captured for the data. And we look at how Pandas makes it easy to now fill that data. And you can see mean, standard deviation, quantiles, stuff like that. And one thing you could do is you can look at the column data types. So there it is. So it tries to do a good job of column data types. Don't be scared away by this object. Object really, in most sense, means strings. So anything that is strings, it puts in as objects. I'm not trying to be technically correct in this talk. I've just had 2 weeks working with Pandas. So this is just how I understand it, and I hope it makes sense to people who are starting with it. So objects is any object, but mostly what I've seen is any strings that it puts in as object. So first thing I do in most data is I don't like the capital names for column names or camel case. I like everything to be lowercase when it comes to column names. So you see how I can actually do just this. So I can say instead of columns, I can just put a new list, which all I'm doing is saying for all the columns in columns, list, convert everything to lower and assign it back to columns. And you would see that after I do this, and let me go and insert a row here, okay. So now if I do train, okay, I'm going to probably put my mic down. If you can't hear me, tell me. Okay, hopefully you'll see this. So now you see everything is in lowercase. All columns are in lowercase, and that was just as simple as that. Okay. So now I say, okay, I don't like sex as a column name. Let me change it to gender. Now I know I'll mess it up if I leave it as sex. So let me add a cell here, and I say, okay, train df.columns of 4. Okay. So that's sex. Okay. So let me just assign it to gender. All I want is. And this is where Pandas does not necessarily work like a list or other Python objects that you have used to, or dictionaries. It looks like it, but it doesn't always work that way. But what's nice is you can go to Stack Overflow and it'll actually, a lot of people have encountered the problem and it'll tell you how it works. So there it is. So let me just show you, these are frustrations that I had and you most likely will have if you're starting with Pandas, that you would do this and you would get this big type error, and don't be scared by it. And that is there for you to know that, hey, you actually cannot change columns a single index like that. Okay, that's all it's saying there. So after some Googling, you'd come to realize there is a rename function. With rename function, you can actually rename columns, individual columns, and you say, hey, rename sex to gender. And if you just rename without this in place equal to true, okay, and this is where Pandas is different from even NumPy. NumPy, changes everything in place by default, okay? Whereas Pandas does not do that all the time. So if you just do this, it'll actually just give you a new data frame with that column change. Whereas if you say in place equal to true, it'll actually change that existing data frame. So you want in place equal to true for most things, unless you want to copy it into a new data frame. So that's just something you will need it. So let's just do some basic operations with it, okay? So let's say I want to see, okay, how do I get one column, okay? There are two ways to do it. And in Pandas, most things, there are more than one way to do things. And you'll see that it's actually more for convenience and it's for good use. So I could do things, I could do a tab, and I could say, okay, now I change everything. So I do gender, and there you have it. So it'll give you, for each row, it'll tell you the gender for this row. So this is the second main Pandas object which you'll encounter. It's called a series object. You don't have to know much in detail to use Pandas to start with, but you will need to know it. These two objects you need to know. One is series, one is data frame. Data frame is the table that you get. Series is each column is a series. And if you think of it that way, I think it will be good for most part. So you see that I can get one column like this. Now and this is the index, and right now the index is just row numbers or the indexes. So you could have a much more complicated index, like you could even make a simple index, like I can make passenger ID as the index here, so that I can query by passenger ID. Okay, so we're not doing it here, but you could do that, right? There's one way to do this. There's another way to do this is by giving almost like a dictionary-like syntax, right? So I could do the same thing here. And why is that two ways? Okay, sometimes you would say, oh, you know what? I want gender and I want, let's say, class. Okay, so you could do this. You can provide. I think you have to give a list here. This where I might. Okay, so this. So there it is, right? So I could actually slice individual columns, okay? And you can actually assign it to a new data frame. You can take this data and assign it to a new data frame. So if you have a large data set, wide data set, and if you say, I want to work with like 5 columns, then you can totally just give those 5 columns here, assign it to a new data frame, and work with the data frame. So It's kind of a very powerful thing when you're trying to slice by columns. And if you have any questions along the way, please feel free to ask. Go ahead.
When you get new data frames, is that just like a view on the same data? Or
No, please, for people who have done this a lot in the room, please correct me if I say things incorrectly. When you do this, Pandas gives you new data frame. It's completely independent of it. It's not a view.
So it's copied in memory, the data itself?
Yes. So, and then now if you say select by a row, okay, select a row. So you could do the same thing. You could do here. Okay, so you could do, I want first 5 rows like this, and that gives you the first 5 rows. Okay, and one of the things that will trip you in Pandas, okay, which did me free, is if you say this, that is not the first row. Okay, it's because Pandas thinks, oh, you're asking for a column named 0. Okay, so because the same syntax is what you would use to get the column, right? The same syntax you're going to use we used it for gender, right? So because of that, it will not understand if you just give one, for a row. And for that, it's got a special syntax for row, which I always use for indexing rows, is IX. So if you say data frame.ix, then you are referring to a row. Data frame with just that, you are referring more than one row. And I usually use IX for everything, I would say, so that you don't get into that trouble. So you can use IX 0 to 6. You can so you always use IX for rows and just the dictionary-like syntax for columns. Then you should be fine. So let's ask a few questions about this data set. Okay. So let's say, how do I show only rows for people that survive?
Ramesh, can you do rows and columns at the same time?
Oh, totally. Thanks for asking that. You can totally do that. And you can say, well, this is a new data frame, so I can totally say, say survive. And then I say name. Okay. Because there's 2 columns, I got to provide a list, and you would see that. So now I've asked for 2 columns, okay, survive and name, and only 6 rows, first 6 rows. Like 0 to 6, like 7 rows here. So that's really what you get. And that's a new data frame. You can actually assign it a new data frame here. Yes?
So what if you just wanted to see a view of that particular subset of the data? Is there a way to do that as well?
I'm not exactly sure.
So if you wanted to do an operation...
I understand your question. Can you get a view of the data, right? It might be a view, I don't know. Okay. So that might be something you might want to Google up later and ask. Sure, that's a good question. I don't know.
Can you access columns with numbers too, like 0 to 6?
Yes, so you can say, hey, you know what, I want columns from survived to name, and it will, hold on a second, sorry, I think you'll not need this. So, yeah, you may be able to, I've seen people use it. Well,
it's backwards, isn't it? You didn't need to do name.
Okay. Yeah. Yeah. Yeah, but you could try it. I think maybe I just need to put on more brackets here because it's a list. But no. So yeah, but it is possible. I've seen people use it. I don't want to be blocked on that statement here because I think I want to show things where you can do. Let's try to ask some questions with this data set and try to get there.
It's a lightning talk. Move on to the next one.
All right, that's good. So if you want to show only people that survived, okay, it's like giving a where clause to your data set. Okay, so train df dot. Okay, so the way you would use a where clause is through NumPy masks. So you can actually give a filter condition over here where I can say, hey, I want to show me, see. F dot survived equal to 1. Okay, so that gives you all the rows of people that survived, and you would see that actually come on. Okay, so that's 342 rows. So 342 people survived of 891, and you can copy it into a new data set and do things with it. Okay, So that's how you do it. You do a filter on it. You can do a filter just this way, and you can now filter on columns as well. You just filter on rows here, right? So go on. So how do you get unique values? How do you get unique values? Just that unique, okay? And this is very, very powerful. Okay, so if you want to see how many survived and how many did not, it is a very powerful function called value counts. So it tells you 549 did not survive, 342 survived, right? So it's very powerful. So now I say, hey, and can I get some distribution of age in this data? Okay, all I have to do is I select the column age and I do a histogram on it, and there it is. It's the traditional matplotlib, with you see skewed left, the 20s and 30s to be the max. Okay, so I just want to show you this picture and then show you that you can actually make it pretty by just this one line of set options in Pandas that basically sets the matplotlib style to a much more nicer looking style. And you can do a lot of things with this also. You can say I want bins equal to 30, right? So now it will give you much more finer bin width if that's of interest. Okay, and I've also looked at Seaborn is another plotting library and which uses matplotlib under the hood, but it provides some niceties to it. So I just want to show you how the same plot will look like in Seaborn. Okay, so I can do bins equal to 30, right? There you go. So the same plot, but looks different, right? So depending upon your flavor, you can choose which plots to use. But they are all using matplotlib under the hood. Okay. So anyway, let me continue. So we saw that age there was some rows where the age was not filled in. Okay. So there are two ways to fill the age. So let me just select this row, select this, and show you those rows and tell you how this is Pandas is really powerful at you can actually. So these are all the rows where 177 rows where it's not a number, which means it did not have value. So there's two ways to do it. I can select those rows and assign the mean age, or Pandas has a convenience function for these, the NA rows, where you can directly say fill NA and provide a value. You can use either flavors, and Pandas usually has convenience function for most common things. So I just filled in I just put both methods in there to see, because you might encounter either one of them in your Googling. So here's one thing: did the gender make a difference? Right? What gender you were? Did it make a difference? And there were 577 males and 314 females. That doesn't tell us anything. So we just want survival by gender. Okay. So group by, I'm hoping we can spend a few minutes and we'll see how it goes. So you see this. It's very similar to a database group by or the Excel pivot table, where you can see by this is the three classes: first, second, third, female, male. Out of 94, 91 survived. Out of 76, 70 survived. So if you're female and first and second class, you probably survive, right? So for the male, not so, right? So this is the image I took from Wes McKinney's book on how you understand group by. So this is a split, apply, combine. I think it's a paper from Adley Wickham and Wes. It's just a diagram that Wes visualized it. So if the way it works is you have it works perfectly for us. So we have the data set. It splits the data set into the individual groups, and then it does any operation you want on it, and then it combines the result. You can think of it as map reduce idea as well. It's very similar. They're all very similar. So conceptually. So this is really what it does. You're splitting it by these groups, these sets of groups. In fact, it gets groups of class and gender. So it's got class 1 female, class 1 male, class 2 female, class 2 male. So I think it took me a while to understand this. So if you actually just break this down, and if you just do this, you'll actually get a group by object. And here's our Pandas is not like regular list in Python, is that if you just do a loop on it, right? If you just do a iterate on it, you'll actually get you're actually getting a tuple back, which is the key and the group, and the key is one female, two male. So there's 6 groups are the keys, and the groups are actually data frames themselves, the sub data frames. So those are individual sub data frames, and that's very powerful idea because then you can do a lot of things with that data frame. Okay, so we're going to do a couple of things here quickly. So before I get to that, I'm going to show you what you cannot do in Excel, which 2 lines of Pandas and Seaborn here does for you. So you see this, it's just a grid plot, and you see this is the female, first class female, second class female, third class. You see that these people did not survive, these people survived. So you see the same idea that we saw through the grid view. You can see it here where only 3 people did not survive on their age groups or ages, and over here as well, only a few did not survive. Here, probably 50% chance that you survived or not. When it comes to males, first class, maybe 50% survived, second not so, third, it's, so you can see that's visually you can see these things, and that is where I say Pandas is very powerful because it creates this ecosystem for you to do these kind of things that you just can't do any other means. And just one more plot on Seaborn. So here you could see the age distribution by the 3 classes. Okay, so here's something interesting. So who paid the highest fare in Titanic did they survive? Okay, so there's something called sort index, and this is all you need to know if you want to sort the data frame. If you want to sort the data frame, it's very simple. Sort index by what column, and by default it sorts ascending, so you have to say ascending equal to false if you want descending sorting. Okay, and this can be a list as well. I can totally give multi-column sort here. Okay, so I'm not doing that here. I'm getting the first 5 rows. So it tells you, hey, these are the 5 people, who paid the maximum fare, and obviously all of them first class, and you can see the fares as well. Okay, so it's as simple as that. Yes.
Did you just slice longitudinal data? Meaning you had
the first 5. I just wanted to show the first 5. Otherwise, you would have shown the whole data.
5 people. It's not the first 5 time frames.
No, first 5 rows. This is first 5 rows. Yeah, first 5 people. Yes, totally. Thanks. Yeah. So sort index is all you need to know to sort by any column in data frame. It's okay. So now here is where something gets interesting, where I would say it's challenging to do it in SQL. Okay. So tell me the top 2 people in each class that are paid highest. Okay. Give me the top 2 in first class, top 2 in second class, top 2 in third class. Okay. That's hard in SQL. Right, so maybe some of you can, but I just can't, and I just use Pandas here, and this is all it takes. Right, I can tell you this is first, second, and third, top 2 by what they paid. So here it is, what they paid: $5 $73. It's probably not dollars, pounds, but you get the idea. So okay, so here I want to just unpack this a little bit, and then hopefully you can go back and research this more on your own. So when you do a group by, we just saw that it actually gives you a tuple bag, which is a key, and a grouped data frame. Okay, and on the grouped data frame, you can use this function called apply. You can apply on the group data frame, and you can do any of the Pandas built-in functions or NumPy built-in functions, or you can provide your own functions, and that is what I've done here. And you can say top n, okay, and then you can say, hey, give me top n, and you just use the group, what field I want to apply on, and how many rows I want. All I'm saying is I'm using the same thing, sort index. It's very powerful. Sort index by field, whatever field is fair, ascending is false, I'm going to give you 2 rows, and that's it. So this, it took me a long time to understand how this grouped concept worked. But once you try it a few times, you will see that this is very powerful stuff. Okay, so you can the same thing. You can say who are the 2 youngest in the data. It's the same idea, right? You can get the 2 youngest in each of this class, right? So you will find a lot of different questions that you can quickly answer in Pandas that you might find much more challenging in Excel or in other data analysis tools. And so that is how you do an apply. When you apply, you're applying for the entire data frame. Whereas if you're applying on a single column, okay, you use a map. That's it. So if you're doing it on a single field, use map, if you're applying on entire data frame as a grouped object, use apply. Okay, so this is how I understand it, and you don't have to write lambda functions. You don't have to write very complex functions. Very simple function. All it says is, okay, if it is male, I want to create a new column called gender value. If it is male, I want 1. If it is female, I want 0. That's it, right? This is a simple function which takes a value. Value is male 1, otherwise 0, and you can just say training data frame column gender map, and I call this function. It just gives you, and I can assign it to a new column. This column doesn't exist in the data frame, right? Doesn't exist in CSV. I create a new column just like that. Okay, so you can totally see data frame now, and you will have this new column there. And I'm going to continue without that. Just getting there. Go ahead.
You can simplify that function. You can just say return int of value equal male.
Totally, yes. I just put it in there because mostly for myself, but also maybe other people may not fully be so far, into Python that putting it down, yes, eventually you grow into that kind of syntax. Definitely, I agree. Yeah. I've only used Python for a year. Mostly use Flask and web development stuff. So, but I love it. So anyway, so if you want to drop the column, we didn't see the rows there. We could totally see that. Okay, so we created a new column, train underscore df. So you'd see that there is a new column there. Okay, and now say, you know what? I actually don't want that column, right? So you can totally drop that column. All you have to say is drop that column, and drop is one of those functions where you can drop rows and drop columns. Okay, that's why you have to give this access equal to 1 if you want to drop columns. So you would see where the same method can be used for both rows and columns. You would have to use the access, and access is really, access 0 is mostly rows, access 1 is columns. But I think there are a couple of functions where it's reversed, but in this one, so all you have to say is gender value, and here you see in place equal true, because these are things that modify the data frame. I think Pandas does not do it in place automatically. It doesn't want to surprise you. So you will have explicitly say, I want to happen in place. So I'll just drop the column right there. So I just want to show you a couple of common mistakes that I did that you might encounter when you use Python or Pandas particularly. Is it's not a list. So let's say you want to do, you want to loop on a data frame. You would mostly not do loop on data frame. With functions like apply, functions like map, you should not be looping on data frame. Okay, because you're talking about large data sets, you don't want 10,000 million loops going on. But let's just say you want to loop on it, right? So just to iteration on it, just to almost towards the end of this here. So for row in train df. So what it really iterated on is the columns there. It did not iterate on the rows here. Okay, so for you to iterate on the rows, you will actually have to say dot iter rows. Okay, so iter rows. Okay, so you do not have to do this, but if you try to say, hey, all I want is just iterate on it just to see what it is, and this is how you do it. Okay, so and again it actually returns back two things, tuple, which is really a key and a row, and row is actually a series object. It actually gives you a copy of the series object. So here is another example, is where if you actually try and say, hey, you know what, actually I want to change that row, if you just modify the series object, it does not modify the data frame. Okay, so because it's a copy of the row. So it does not modify the data frame. For you to modify the data frame, you will actually have to use a data frame, go back to the index for that key, on that column, modify it. You should not do these things, but if you end up doing it, you might get frustrated. Why is this not updating my rows? So you should use apply and map. Anytime you want to modify anything in Pandas, apply and map. Okay. So another thing that will trip you is you say, hey, how do I join based on, get all the rows that survived and first class, okay? So this is how it is, right? You do an and over here, and you do this, it will give you an error. It's because Pandas expects you to wrap this into, its own parentheses. because it's not the Python and clause, it's actually the ampersand sign there. So this will work, and sometimes it may not work, and you have to do a parenthesis on top of it, right? Sometimes, okay, but I think that's probably, so anyway, so I just use it all the time. So this is how you filter multiple columns. So that's really what I want to show you today is an overview of Pandas, and hopefully excite you enough to go and try it, and do some things with it, and visualize, display things that you could do in Pandas you can't do. Go ahead.
Does it have any support for multi-dimensional longitudinal data, meaning like data that you have time and some other things about people, what happened to them within time, and you don't have necessarily all the data for all the time frames? Does it have support in this? Yeah, totally. I think Pandas is one of the strong things is the time dimension. So it actually does a lot of things at a time. I don't fully understand everything. So it totally does a lot of things at a time. So I was just trying to do some things with the Walmart data, which is actually 500,000 rows. It's not a lot of data, but still. So I was just trying to say simple things like, hey, tell me the top 3 weekends where the sales are higher. So you would see there's Thanksgiving weekend, there's Christmas weekend, no surprise. But for some stores, you would actually see it's not the case. Maybe they are not US, they are international stores, we don't know. So and also you can actually see plotted across time. I just plotted this data. You see how retail is very cyclical. You see January, there's a dip. Thanksgiving is a high. July 4th, there is a high. So you could see how it's very, very simple, right? I didn't do much work with this. It's just a simple thing as plot. So you're saying Pandas handles the time data elements very well.
Very well, yes.
It handles data very well. Okay. This is not exactly what I was asking, but it's okay. The second question is, what happens if you have stratified data? Does Pandas, when it loads a table, does it knows that information is sometimes given, like for example, if I'm giving information about people aged 20 to 30, then 30 to 40, 40 to 50, and this is how it's stratified. Can I ask it what happens with 20-year-olds? Like, will it know that I mean the category of 20 to 30?
Right,
will
yes.
Will it know how to do this on its own, or do I need to help it?
No, you will have a little bit help it probably, but you can actually create your own bins in Pandas, or you can have Pandas create bins for you, so you can bin that kind of values. So the data itself probably has the age, and then you want to stratify it by bins.
No,
so
it's already stratified. I want to just hit the strata.
Yeah, that will be a string. If it's already stratified, if it's a age.
20 to 30, if I ask about 25, it's not 20, it's not 30, it's somewhere in between.
Right.
Does it know to tell me, oh yes, you mean the 20 to 30 strata?
Maybe not. It depends on how you show the data. You will have to sparse it in 2 columns, and you can say where age 1 is greater than 20, age 2 is less than 40. So you can do that by using AND clause. Just like you do any query in a database. If there's one field has multiple information in it, you'll have to split that information to query that. But
we can talk later.
Yes. So yeah, I've just scratched the surface of Pandas, honestly, and I would strongly encourage you to take your own data set and go and explore it. And if you just want some free data set, you could go to kaggle.com and then download some data sets that they have in there and play around with it and ask some interesting questions out of it. And what is so great about Pandas really is it's tightly integrated into Matplotlib, not Matplotlib, but I mean the higher level libraries like Seaborn or or many other libraries. It's tightly integrated for you to do quickly plotting, and also you can take data NumPy arrays out of Pandas and feed it right into scikit-learn. Now you're doing predictive modeling after you do data munging in one workflow, and I think that's very powerful. So, sure.
Side question. So you showed the fascinating figure plotting with Seaborn. Have you ever tried the ggplot library?
Yes, I've tried ggplot library actually, but it did not work in Pandas 0.14. So I've actually tried ggplot on this, and yeah, I tried ggplot also. It did not work for 0.14. It was using some older
APIs, so it was giving me some errors, so I said, let me just use CBON. Just go ahead.
For this, for the plot that we're looking at right here,
yes.
The survived axis is binary, correct?
Yes.
So is it adding jitter to the data?
Yes, I added. So let me show you here. If you look at the code here, I added X jitter. I added jitter here. Yes.
Oh, so it's built in as a.
Well, by default there is no jitter. I added jitter into it.
Right,
Yes.
but I mean, the notion of jitter is.
Yes. C1 is very powerful. Although it's the APIs have been changing a bit, so you might find that you use it and the APIs are changing because it's evolving quite a bit. So, you had a question?
I had the same question.
Okay. Yeah, it's very powerful, and I think for that one reason alone, all you're giving is, hey, here's a data frame. I want rows by gender, columns by this, things that it's not a lot of lines. It's like 2 lines, right? So that's what I love about Python. The ecosystem of libraries is just so nice that you don't have to. All you need to know is how to use them and
Are you adding jitter so the points are not on top?
Yeah, so that you can see the density of information, right? So if I don't add jitter, you would not know that the density over here is higher than density over here. That's just to show you that there are more people in that third class, right? Of math as well, and that did not survive. So just to give you see the information visually and give you density values.
We're running up on close on time here. So one more
Can you make the notebooks available to us?
Yeah, it is available on my GitHub handle. So my GitHub handle is this is my GitHub handle. So Sampath Web, it's my GitHub handle, and my notebooks are available there. So Pandas. Sorry? Yeah, I'll put this in the Meetup notes so that you know where to look at it. All right, thank you. Thanks guys.